Okay, welcome to 9.6, the converse of the Pythagorean Theorem. Today, our learning target is to understand the converse of the Pythagorean Theorem. Our success criteria will be measured by our ability to explain the converse of the Pythagorean Theorem, our ability to identify right triangles when we are given three side lengths, and so I'm right here. Let me see if I can make that bigger. That one, and I like this color. Okay, so here's our learning target, and these are our success criteria. That last success criteria is going to be our ability to identify right triangles in a coordinate plane. Okay, so there we go. Okay, let's go ahead and start right here with the key idea. So the converse of the Pythagorean theorem basically states that if a squared plus b squared equals c squared, then you have a right triangle. So they're going to give you the side lengths for a, b, and c, and you have to plug those in to the Pythagorean theorem. And if this is true, then it's a right triangle. If it's not true, then it's not a right triangle. And that's basically all that the Pythagorean theorem is. It's just basically saying if a squared plus b squared equals c squared, then you have a right triangle. So let's go ahead and we're going to look then at example 1. Example 1 asks us to tell whether each triangle is a right triangle. So we're going to look at our legs here. Our legs are 9. So A equals 9 and B equals 40. And then C, our hypotenuse there is 41. So all we're going to do is we're going to say if 9 squared plus 40 squared equals 41 squared, then we have a right triangle. Okay, so we're going to put that little question mark above that. So 9 squared is 81, 40 squared is 1600, and 41 squared is 1681. Okay, so 81 plus 1600 is 1681, and that is equal to 1681. So all that means is in example 1, the triangle is a right triangle. And right triangle means that it has this angle right here is going to go ahead and equal 90 degrees. Okay? That's all that we do. That's all we're doing. We're just proving that it's a right triangle by plugging the legs and the hypotenuse into the Pythagorean theorem. Okay? So let me go ahead and erase. That was A. Now we're going to look at B. I have to delete this thing. Okay, let's look at B now. B, they give us a triangle, and it looks like this angle right here might be a right angle. Okay, so remember my legs are the ones that are connected to the right angle. That means my legs are going to be 12 and 18, and we want to know if we square them, are they equal to 24 squared? So 12 squared is 144. 18 squared is 324. Why did I write equals? That's a plus sign. And 24 squared is 576. Okay? We've got 8, 6, 4. 468 is not equal to 576. So this is not a right triangle. Because they are not equal, because a squared plus b squared does not equal c squared, this is not a right triangle. And if you look at it, you can kind of see that. It doesn't look like that one is a perfect right angle. So a good thing to keep in mind, this is a good note right here, okay? I know I told you guys this. When you're dealing with the Pythagorean theorem, that longest side is always going to be your hypotenuse, okay? 24 was the longest side, so even without looking at the picture, I would have known that that was my hypotenuse. If they just gave me side lengths, if they didn't show me a picture, if they just gave me random side lengths, I would need to know then that the longest side is always going to be that right angle. Okay, I want you to pause and I want you to do try it 1 and try it 2. And here's what I'm talking about. They didn't give you a picture, so you need to be able to use that longest side, knowing that longest side is going to be your hypotenuse, so the longest side is C. Go ahead and pause and solve 1 and 2, and when you come back, I will have your answers. All right, for number 1, the answer is no, it's not a right triangle. 20 squared plus 21 squared does not equal 28 squared, okay? For number 2, the answer is yes. And so that means that 1 squared plus 0.75 squared is equal to 1.25 squared, okay? All right, let's go ahead. Oop, wrong button. Let's go ahead and move on to example 2. In example 2 is a lot of work. I'm not even going to lie. It's a lot of work. We're going to get through it, though. We're going to do this. Okay, you'll notice in example 2, we have this. I'm going to kind of zoom in. We have this triangle right here. So you have this triangle right here. Whoops, hold on. Erase. Okay. You have this triangle right here, and you'll notice that it doesn't go along, that the only one we can tell the distance on is this side right here being 5 units. The rest of them are at a diagonal, so we can't tell the side lengths. But you'll also notice that we can form a couple of different right triangles on it, if you see those right there. So what we're going to do is we're going to use these distances right here to determine the hypotenuse that's here. And then we're going to use these distances here to determine the hypotenuse here that end up being the legs of this triangle right here. I know, that's a lot. It's a lot. We're going to have to do quite a bit of work here. But trust me, we can do it. We can get through it. So let me go ahead and delete all of this stuff here so that we can see what we're working with. Okay. And then I'm going to go ahead and zoom out, reposition. I'm getting the hang of this stuff, guys. All right. So the first thing we're going to do is we're going to want to find this hypotenuse right here. So the distance between point A and B. So A and B. And so we know that this triangle right here has side lengths of 4 and 2. So we're going to say 4 squared plus 2 squared equals C squared. So that's 16 plus 4 equals C squared. And so C squared equals 20. And so C equals the square root of 20. And we're just going to leave it like that. Okay? So that's that first part. That's where that comes from. That's how they found that. So I'm just going to leave that circled. I'm going to go ahead and erase so I can find that other piece now. Okay. Now we need to find the distance between A and C right here. We're going to find the distance right there between A and C. And so we know that that first leg is 1 squared and that second leg is 2 squared and they equal C squared. And so we have 1 plus 4 equals C squared. So C equals the square root of 5. And that's where that comes from right there. So now we found, let me come over here and delete some stuff. And I'll show you. What we found is we have found that this distance right here is the square root of 20. And this distance right here is the square root of 5. And those are both legs. And so what we're going to do is we're going to use those to see if this is a right triangle by seeing if A squared plus B squared equals C squared. So we know these are our legs. So the square root of 20 squared plus the square root of 5 squared equals c squared. Okay? Now remember that when we're dealing with square roots, if we square them, then they cancel out. So what we're left with is that 20 plus 5 equals c squared. So 25 equals c squared. C equals the square root of 25, which is 5. And because that is true, we proved that 25 equals 25, right? Okay, we proved that this one was 5. Then we know that, yes, this is a right triangle. Okay? So the points form a right triangle. Okay? So I'm going to go ahead and erase a whole bunch of stuff because we're all over the place on that one. And I want you to pause and I want you to try to do example, try it 3 and 4. I'm going to delete some of these things because they're in my way. Okay. That's really all I need to delete. So let's go ahead and look at try it 3 and try it 4. Try it 3, we have some points here. Let's see. We have D at -4, 0. We have E at -2, 3. And we have F at 1, 0. Okay? So what would be a really good thing to do here is it would be a really good thing to draw a coordinate plane. So I am going to change my background to graphing paper, and then I'm just going to draw in, I'm going to draw in a little graph right here. Okay, so I can kind of see this. Now 1, 0 over 1 up 0, that's going to put a point right here. Okay, -2, 3, -2 up 3, that puts a point right here. And -4, 0, 1, 2, 3, 4, that puts a point right here. And if I connect all of these, I have a triangle. Now the only distance that's straight is this distance right here. From -4 to 1, that's a distance of 5. Okay, so now I have to find this distance here and this distance here, but they're on diagonals. So the best way to do that is going to be to draw a triangle here where I can see, okay, I can see those nice right angles, those nice, I know that this is a right triangle because it's got those nice angles. So I know this distance here is 3 and this distance here is 2, and that's going to help me find this distance right here. So 3 squared plus 2 squared, that's 9, plus 4, that's 15. So this distance right here is going to be the square root of 15. And we're just going to leave it like that for right now. We're just going to leave it. I'm sorry, that's 13. Hello, Miss Crewy. 13, the square root of 13. Okay? And then we can go ahead and do the same thing with this distance right here. We can come off of here and down to here. And there we've got that nice right triangle right there where we can see 1, 2, 3, 1, 2, 3. So 3 squared plus 3 squared equals c squared. So 9 plus 9 equals 18. Okay. So we know that this distance right here is the square root of 18. So now we can use that. And if we can prove that the square root of 13 plus the square root of 18 equals 5, then it's a right triangle. If the square root of 13 plus the square root of 18 does not equal 5, then it's not a right triangle. So I'm just going to delete some stuff right here. I'm going to go with a pretty rainbow color. Square root of 13 squared plus, well, that's going to have to be smaller. Hold on. Sorry if you can hear my dogs barking in the background. They bark like crazy all the time. Square root of 13 squared plus the square root of 18 squared should equal 5. Okay, 5 squared. Okay, so we're going to have some canceling going on here. These are going to cancel. And we're going to be left with 13 plus 18 equaling 25, because 5 squared is 25. So 13 plus 18 was at 8, 9, 10, 11, 31. 31 does not equal 25. So this one right here, try it number 3 is no. And I hope that what you guys saw was how I graphed that, how I did this graph up here to really demonstrate and draw out these points. Okay? Now, there's a lot of deleting that's going to have to happen here, because I drew lots of triangles and lots of squares. Okay. It's dark outside. It's like 7:30 right now. And so my dogs can't see anything. And so they just bark. They just bark to hear themselves bark. Okay, let's look at triad number 4. And I'm working through these with you guys because I know that these are a little bit harder to do. So we've got J, K, and L. You can go ahead, if you got this and you think you got it, then you can go ahead and skip until you see me show the answer. Okay, so again, I am going to graph these. Okay, so we've got negative 3, 0, 2, 3, negative 3, 0, 1, negative 3, and 4, 1. Okay, here's my triangle. There's my triangle. Whoa, it moved it. Hold on. There's my triangle. Now, none of these, not a single one of these form a straight line. So guess what I'm going to have to do? I'm going to have to find the distance of 3 of them using right angles, using connecting these. Okay, so there's one right there. Okay, and here I can see this is 3. 1, 2, 3, 4. This is 4. 3 squared plus 4 squared, that's 9 plus 16. So that's 25. So that means this distance right here is 5. And I know that a 3-4 triangle is a thing. That's just one I know. Okay, so that's 5. And that's going to be one of my legs. So I'm just going to make a note over here that A is equal to 5, because I know I'm going to have to erase some of this stuff here. All right, I've got another triangle that can be formed right there. 1, 2, 3. 1, 2, 3, 4. So again, we're going to have a 3, 4, 5. I'm just making sure that, so that's B is 5. Okay. And then the last one here, let me see, I got to figure out how to make this a triangle. Okay, it's a really small triangle, but it's a triangle. It's right there. That's a triangle. So we've got 1, and we've got 1, 2, 3, 4, 5, 6, 7. So that's 49 plus 1 is 50 squared. Okay? I hope I'm doing this right. I hope I didn't mess up anywhere. So 5 squared plus 5 squared has to equal 50 squared. So that's 25 plus 25 equals 50. The square root of 50, so how is that going to work, guys? If I square root this side and I square root this side, these cancel, and I'm left with 50 equals 50. 50 equals 50. Whoop, whoop. So this one is yes, which is right. I'm checking my answer. It's right. Okay. So I hope that made sense to all of you, because that was a lot of work. Okay, I was going to delete, but I don't actually have to delete. I just have to scroll down. Okay. Let's go ahead and go on to example 3, modeling real life. And it's going to be the same thing. It says you design a football play in which a player runs down the field, makes a 90-degree turn, and runs to the corner of the end zone. Your friend ran the play as shown, where each grid line represents 10 feet. Did your friend run the play correctly? So we know that this is supposed to be a 90-degree turn, okay? So what we're looking at here is they've already got all these triangles for us on here. So we have to find the lengths, okay? So this is actually called the distance formula right here. You guys, we've done this. This is the distance formula. And basically it's side squared plus side squared equals a square root. So let's go ahead and look at this. Okay. So that's this one right here. So 30 squared plus 30 squared is 900 plus 900, which equals 1800. Okay. So we would square root that to find the answer, to find out what this distance, that's this distance right here, okay? And then when we look here, we need to find this distance. So we do 50 squared plus 50 squared, and that's 2,500, sorry, plus 2,500, which is going to equal the square root of 5,000. And that's that distance right there. And then we've got 20 squared plus 80 squared, and that's going to be 400 plus 6,400 is going to equal 6,800. The square root of that. So all we need to do now is we need to figure out which one of these is the biggest one, so we know which one is our hypotenuse. Obviously, it's the 6,800. So then we're just going to plug it into the Pythagorean theorem. I'm going to go ahead and erase all of this because it's all right here. So I'm going to go ahead and erase all of this so that I can show you how this works out. Not that you can't look at it and see, but I swear it's better when I do it. Haha. I don't know. All right. So we're going to do the square root of 1,800 squared plus the square root of 5,000 squared. Okay, that's not working right there. My little thing's in the way. I'll move down a little bit. All right. Square root of 1,800 squared plus the square root of 5,000 squared should equal the square root of 6,800 squared. Okay, so we got a lot of crap canceling each other out here. This cancels, and this cancels. Go away, cancels. So basically, all we're left with is that 1,800 plus 5,000 should equal 6,800. So 5 plus 1 is 6, 8 plus 0 is 8, 0, 0 equals 6, 8, 0, 0. It does equal. So, yes, your friend made the 90-degree turn. They ran the play right. Bam, right there. Okay? I know that's a lot. I know that trying to identify how these triangles made right here can be a little confusing, but it's doing it the same way that you found the distance before. You're just doing it at an angle this time instead of having nice, perfect straight lines. So that might be something good to practice, is just plotting some triangles and trying to identify how you can make some straight lines on them. So for instance, I've got my grid right here. Here's my grid. I might just plot 3 random points. A point, a point, and a point, and then connect those points to make a triangle, and then trying to identify if this is a right triangle. Now, obviously, we can all look at this one and see that it's not, but where can I make the right triangles? That's the point. Where can I make the right triangles? So see, there's a right triangle. Now, if I just come down from this one and over, there's a right triangle. And then the same thing here. These ones actually do form a straight line right here, okay? So this one might actually be a right angle. Okay? So just, practice that a little bit. Just practice graphing some points. Make sure I make this one not. Okay. So I graph some points, connect them. There's my triangle. Now find the right angles. Find the right triangles. So from this one, starting at this point right here, I'm going to go up till I get even with this point right here. So I'm even with this point, and then I'm just going to go over, and I've made that right triangle. Okay, it even made it for you. And then I'm going to count. This is 1, 2. This is 1, 2, 3, 4. So I've got a 2, 4, and I need to figure out what my hypotenuse is right there. Okay? And same thing with this one. I'm going to come over until I'm even with this point, and then I'm going to come down, and that forms my nice right triangle right there. 1, 2, 3, 4. 1, 2, and that can give me my leg right there. Same thing with this one. I'm going to come down until I'm even with this point, and then I'm going to come across, and that gives me that nice right triangle right there. 1, 2, 1, 2, 3, 4, 5, 6. 6 and 2 for that triangle to find that hypotenuse. Once I've found those 3 right there, I can use that information, plug that in, making my longest one the hypotenuse to figure out if a squared plus b squared equals c squared. That's basically the entire lesson again in a nutshell. So I hope this all helps. Go do your homework, and then you will have a quiz probably assigned tomorrow, so be on the lookout for that. All right, if you have any questions, I will be available on Zoom meeting tomorrow from 1 to 2. I know a couple of you tried to get a hold of me yesterday, and I was in a meeting with the teachers and Mrs. Niermeyer, so I apologize for that. But I will be available on Zoom tomorrow from 1 to 2, or you can call my classroom phone at 520-896-3011, or you can email me and you all have my email. All right, have a good day and do good things.